Good morning. My name is Steve Marr. I'm with Risk Management Professionals, and welcome to our webinar this morning. This is part of our ongoing series in process safety management, risk management programs, and SEMS, and it's an outgrowth of our consulting activities in those areas. We use this as an opportunity to share some of our expertise and tips with the general public, and also we use it internally to try to convey best practices and make sure that we're always at the top of the game with respect to the engineering services and the things that we provide. As part of our, before I introduce our speaker, let me tell you about the topic. The topic today is going to focus on IIAR Bulletin 109 audits that are an important part of your mechanical integrity program for PSM, RMP, and also some of the state accidental release prevention programs such as CalARP. Before I introduce the speaker, let me talk a little bit about logistics. The vehicle we're using for this broadcast is WebEx. It allows two-way interactive communications with large numbers of participants. However, so that you can get work done in your office, answer phone calls, conduct meetings, or whatever, all the participants that are dialing or are seeing us online are being put on mute so that you can go about your normal activities. During the course of the broadcast, if you do have any technical problems, please feel free to call our office. The number is on the screen. You're also welcome to dial 877-532-0806, and somebody will work with you to try to get any technical issues resolved. What you're going to see on your screen is primarily a PowerPoint presentation, and we're also going to show you some excerpts from the Bulletin 109 checklist. You'll also see in the upper right-hand corner a video of the presenter. Right now you should see an image of me, and you're also welcome to resize it any way you'd like. A lot of people would like to make my image smaller. You're welcome to do that. Just grab the side of the window and move it as you see fit. So we'll be focusing on the PowerPoint presentation in just a few minutes. In terms of communications, dialing in is fine. Give us a call if you're having any technical problems or if you have any questions. Also, during the presentation, there's a chat window. You can activate that if you hover your mouse cursor at the top of the screen. You'll see a pop-up menu come down from the top. There'll be a chat window. You can communicate with our producer, Solveig Sather, who'll be using the moniker RMP CORP. And you can go ahead and pose questions, try to resolve technical issues, etc. Also, as we proceed with the webinar, towards the end, you're going to have an opportunity to pose questions to the presenter at that time, and also think about questions during the course of the presentation. But at that time, you're welcome to pose the questions via the chat window. Our producer will echo those to the presenters and get your question answered. You're also, if you'd like to initiate a discussion or ask the question directly, you can ask the producer to unmute you and go ahead and you can ask the question verbally to the presenters. All right, so I guess without further ado, I'd like to go ahead and get things rolling. Let me introduce Scott Goad. Scott Goad is our main presenter today. He has an extensive background in ammonia refrigeration systems, process safety management, and risk management program development. His educational background includes mechanical engineering technology, and he's been focusing on PSM and RMP and putting together quality programs since 2002. He is considered to be a subject matter expert in ammonia refrigeration system design, PSM and RMP applications, and as that, and consistent with the overall theme of our outreach program, he'd like to share some tips, some of his experiences, and some key issues and background associated with conducting an effective IIAR Bulletin 109 audit. So let me ask Scott to join me on the podium. Thank you. This is for you, sir.
Thank you, sir. For those watching, bear with me. This is my first time to be a presenter in this method, so I will try to not look too stiff and see I'm being told to move over a little bit and try to go through this. And hopefully it's informative. Like Steve said, I'm going to talk about your mechanical integrity inspections using the B109 forms as the tool to conduct these inspections. But Steve told you a little bit about myself, but I want to just add a little bit more about myself here. I've been in the ammonia refrigeration business since 2002. I started out my career with consulting firms and providing consulting services, and that's where I learned PSM. But where I really learned what PSM is all about and how it applies to what the facilities have to do was for the past 8 years, I've been a corporate PSM manager for 2 separate Fortune 500 food processing companies, and I learned something very valuable there. And I learned that consultants, they provide us a great service when it comes to PSM, but when it comes to the implementation, the management, the driving forward of PSM, that has to come from somebody within the company. You can't rely on a consultant to make that happen. You use the consultants, they're there to provide a service, but we've got to drive these forward. And I hope that that comes out in the way my presentation goes today, because I'm talking more directly about not what you can get a consultant to do for you, but what you need to do in-house to conduct these mechanical integrity inspections and what you need to be looking for. Like Steve said, I have extensive experience with ammonia refrigeration design and mechanical integrity and maintaining good quality systems. So I hope that I'll be able to convey that to you guys in this presentation. First, I want to talk about what I think PSM is. This is Scott Go's definition of what PSM is, but PSM, RMP, they're really the same thing. I won't go into the semantics of PSM, RMP, and CalARP, but basically what I think PSM is it's a business model. It was created not as something we have to comply with, here's a law and I want you to comply with it, so develop a bunch of binders and put them on the shelf to comply. It's a business model. Just like any business has to run by a model, it's a business model for running and managing a highly hazardous chemical system. And in the food industry, that just happens to be our highly hazardous chemical is anhydrous ammonia. It could be anything. There's thousands of highly hazardous or flammable or explosive chemicals that have to be managed in this way. Also, another thing is, this is a thing where we have to convince management of this, is that PSM isn't something that's done. I've dealt with this for years, that when we can get that PSM stuff done, then we can move on to other and more important things. But I want to challenge you. I want to ask you, if you run a refrigeration system, what do you do in your day that doesn't touch on one of the 14 elements of PSM? You know, if you're going to fix a piece of equipment, that's mechanical integrity, and that's kind of the focus today. If you're going to train somebody, it's training. But it's a business model that tells us all the things we should be doing to safely run our refrigeration systems. And PSM is never done. So, you know, it's something we have to convince the people we report to that you know, I'm never going to be done. I've got next year I got to do mechanical integrity inspections again. And so today's focus is going to be on the IIAR Bulletin 109 forms for conducting mechanical integrity inspections. I'm not going to really focus on what the form says. That could be pretty boring. We are going to look at the forms a couple of times just to highlight a few things that are on the forms, but I want to talk about the background stuff, the things that you need to be looking for to fill out the forms correctly. So first thing is we need to talk about the regulation. I mean, the reason we're doing these inspections is because this business model that I just presented, which is called 29 CFR 1910-119, says we need to do these inspections. And it says that inspections shall be performed on process equipment. And in the food business, there's a confusion here of process. We think about the process as being, you know, I process strawberries, or I process chickens, or I process something. Well, that's not, when it comes to PSM, RMP, CalARP, from a regulatory standpoint, we are not a food processor. We are a chemical company. And so our process is our refrigeration system. That is our process. So when it says perform inspections on our process equipment, that means our refrigeration equipment. That's our process. Inspections and testing procedures shall be performed using, and this, to me, I don't like this term, but everybody in the industry is throwing out here this REGA-GAP thing, generally accepted and good engineering practices. The REGA-GAP acronym I'm not real thrilled with. It's kind of a clumsy thing to say, but that's a critical part of everything PSM, is that it's follows good engineering practices. So the Bulletin 109 is a guide to following good engineering practices when conducting our annual visual inspections. Frequency of inspections and testing shall be consistent with manufacturer's recommendations. And beyond that, our industry recommendation. IIAR is kind of our industry guiding light when it comes to regulations, guidelines, and programs. So they spell out the frequency that they want us to do these inspections. They say we have to do them annually ourselves, and every 5th year we have to get a third-party inspector to come and do it. And we'll talk more about that. Employers shall document each inspection and test. That's the form. The B109 is the documentation of this. We need to document what piece of equipment we inspected and who did the inspection. And then finally, deficiencies. The whole reason we're doing these inspections is to find areas of improvement, areas where we can make things better. So we need to document these deficiencies. But this is, we'll talk about this later, this is kind of a trap. We've got to make sure if we write a deficiency, or if one of our employees writes a deficiency on a B109 sheet, that we somehow track that and lead to resolution, because a regulator finds it written on a B109 sheet and we don't have any way of saying we fixed it. That could cause us problems in the future. So 3 types of inspections that have to be done. Annually, you should do the B109 in-house inspections. Every 5th year, it would be basically the same inspection, but you need a different set of eyes doing it. You need an outside engineering firm or a refrigeration contractor, somebody that you feel comfortable with coming in and doing the inspection, just so that we have another set of eyes. And then non-destructive testing. There's no clear-cut rules when it comes to non-destructive testing, but it does say we have to do some level of non-destructive testing. I'm going to talk about that more. I think it needs to be in conjunction with our visual inspections and as a follow-up to our visual inspections, not as something where we just do it just to do it. Annual visual inspections. Make a plan, get it done. This isn't something you want to remember in December. Oh yeah, I forgot. I got to do that again this year. This is something you need to plan for, have a plan, move and enact the plan. Smaller facilities, you could pick a week. You know, the 3rd week of April is when we do all of our annual visual inspections, or you pick a time to do it because you only have so much equipment. But large facilities, places with lots and lots of equipment, it should be part of your PM program. It should be a PM that whatever software you use. I know a lot of large companies are using SAP these days to manage their PM programs. It should be a program that it should come out as a PM that says inspect this piece of equipment. However, when it is done, make sure that however you do it, whenever you do it, just make sure you get all the equipment done and tested and inspected, and that we need to make sure that these are separate from our regular PMs, and that we do document that we've inspected every piece of equipment every year. 5th year inspections. This is a tricky subject because, maybe not a tricky subject, but a tricky thing to implement, because there's no consistency in the industry. You're going to hire who you're going to hire. You're going to hire a consulting firm, a consulting engineering firm, or a refrigeration contractor, and they all have different skill sets, different levels of knowledge, different ways of conducting these. And in my experience as an in-house corporate PSM guy, I would hire firm A for one facility and firm B for another facility, and in my mind, in visiting these facilities, they were in about the same condition, about the same size. And one facility I had, the contractor I hired, he gave me 5 recommendations for the whole facility. And 5, I mean, he missed a lot of things. And then another facility that was very similar, a different contractor was hired, he gave us 850 recommendations. Well, I don't know how you guys manage your recommendations and how often you review them, but can you imagine having to go through 850 recommendations and reviewing them on a monthly basis or something and driving them forward? That's a huge task. So there's got to be ways of grouping those or something. So you got to carefully pick who you're going to use, and because you don't want anything missed, but you also want it, manageable. And I would assign, this is not a free ticket. This is not, well, every 5th year I don't have to do it. This is every 5th year I have an outside person come. So I would still make it part of your task. I would assign somebody or somebody each shift or whatever, however you do it. I would make sure that you have one of your operators working with the inspector. Your operators and you know better what the deficiencies are than the person who's just walked in the facility today for the first time. So you want to keep them with them so that they can help guide them through the facility and show them the deficiencies. And then require the inspector to deliver the inspection report in a formal meeting format. Don't just let him email you the report and say, here's my findings. Do it in a formal, so that you can review the findings before you accept it, especially when you get 850 of them, because sometimes they're not necessarily deficiencies as much as they may be a suggestion of, I think you ought to do this. So make sure that when you get the final report, that there are deficiencies, the recommendations you can live with. It's not your place to tailor without addressing the recommendation, but you can talk to the inspector and have them go back and rewrite the report and make changes after a dialogue has occurred, so that we can have a manageable group of recommendations. Even with the company gives you 5, I mean, if a company came and had a formal meeting with me and said, here's my 5 recommendations, I would say, these are the 50 other things I think you should have found. Maybe you ought to go look at the place again. So, non-destructive testing. Non-destructive testing is typically done as a follow-up to, this is my opinion, I think you should do it as a follow-up to visual inspection concerns. I don't think you should just hire a non-destructive testing company to come in and do ultrasonic thickness testing of your piping just because you felt like you should do it. There's really not a lot of value in it, and the snapshots of the little random places that they choose to inspect don't give you a lot of information. So don't just do it to say you did it. Avoid the types of inspection, which basically is ultrasonic thickness testing, where they have to drill a hole in your insulation and they put the little probe in, and then they have to fill the hole, and that's creating a mechanical integrity issue right there when they do that. So try to avoid companies that have that methodology. There's companies out there that use X-ray and different technologies that give you actually more sample points, do not penetrate your insulation, things like that. Also, regulators want to know you're doing non-destructive testing. Non-destructive testing falls in lots of categories. It's not just pipe thickness testing. So if you have a vibration analysis program or an oil analysis program or ammonia quality testing program, count those as part of your non-destructive testing of your system, so that you can show a regulator, I'm ongoing. I have an ongoing non-destructive testing program. Inspections are not PMs. I want to make this perfectly clear. You need to have a PM program that follows what the manufacturer of the equipment says you should do for the equipment, but that doesn't fulfill the requirement to do the inspection. And the inspection is a separate activity. It's a separate exercise from all the PMs you've done in the year. The reason it's supposed to be totally separate is that when you're working on the equipment and you're fixing it, or you're doing the PMs, that's your focus, is to do the task at hand. But the annual visual inspection is a separate time to go and just look at the equipment and assess how it looks, how it sounds, how it's running, how it's operating, and then document anything that your PMs might have missed. I mean, there's lots of things that don't come up as PMs that could need to be done. A piece of equipment needs to be painted. You got a wiring junction box that the cover fell off of. There's things that you'll see when you just step back and look at it, and you may see them all the time when you're doing your PMs, and you may fix them, but you still need to have a separate, because this is the old adage of PSM, if it's not documented, it didn't happen. So we need to have a separate we need to have a separate inspection where we document that either we didn't, at that day, we didn't see anything wrong, or these are the things we saw wrong, we need to fix them. What to inspect? Going back to the definition, we're inspecting our process equipment. Our processes is our refrigeration system. So all the components of the system, there's a B109 sheet that addresses that. Compressors, pressure vessels, heat exchangers, our evaporators, our condensers, pumps, piping, ventilation, relief valves, and then general safety. Every piece of equipment should fall into that category somewhere. Valves, I guess there's not a sheet just for valves. I think that kind of falls under the piping sheet. Or each piece of equipment has valves associated with it, so you would look at the valves at that time. But other than that, that's a pretty comprehensive list of generically what all the components of a refrigeration system comprise of. Managing your time. Especially with big systems, managing your time is critical, because if you have 1,000 annual visual inspections to do in a year, that's very time consuming. So when you look at the B109 sheet, and we'll look at them in a minute, but when you look at the B109 sheet, there's two sheets. There's a first sheet that gives you all the technical information about the piece of equipment. Model numbers, serial numbers, operating pressures, all this stuff. And then there's a second sheet that is an inspection checklist. It's my feeling that that first sheet should be filled out either when the piece of equipment is first put in service, or if you haven't done it then, do it now. And save all those sheets in a binder that's associated with your process safety information. This is good information to have at any time. If you have to look up a model number on the motor for a fan or something, this is a great resource to go to. And that information, that first sheet, should never change unless you've had an MOC process. You've done something to that piece of equipment that caused a change in it. And that could lead us into a whole other webinar of what is an MOC. Say a compressor. If you change the motor on a compressor, the new motor is going to have a different serial number than the old motor. So this, in my mind, institutes an MOC process, because now I have a PSM document, the front page of the B109, that has to be updated with the new serial number. So as long as you track and manage these changes like this, that front page should not have to be filled out every year. Your operator shouldn't have to climb up on pieces of equipment and read these dusty, dirty tags to try to get the information that they got last year. It should be managed as part of the MOC process. So that frees us up to only have to do the visual inspections on the second page, which talk about the integrity of the piece of equipment. And you can spend more time, be more thorough doing that inspection, and get through the whole process in a more timely manner if that's what we're focusing on as the second page. First mechanical integrity point I'm going to talk about is piping. Piping is probably the hardest part of our system to conduct an inspection on, because you got piping going everywhere. How do you figure out how to break up the facility so that how many piping inspection sheets? You can't just use one piping inspection sheet for the whole facility. Do you have one for one header, or do you have one for piping that's inside? You got to come up with a plan, and there's no set, this is how I would do it. You have to do it, every facility is different, so you have to come up with a plan of your own of how to break down the areas that you're going to inspect, how to properly document the inspections, and how to document where the deficiencies were. If you see bad insulation somewhere, you need to be able to go back and know, well, where was that place that I found the bad insulation, whether it's tagging it with a number out in the field or associating it with a piece of equipment or a valve group. Somehow identify so that when you're going through the recommendations, trying to develop a plan to resolve recommendations, you know where that bad area was, or if it's piping that's rusted and you want to get non-destructive testing, where was that? So that's got to be a critical part of developing this piping inspection plan is how do I remember what part of the system I was looking at when I saw that deficiency. Each facility must come up with their own plan. So what I'm going to discuss is what to look for, not how to develop the plan, because everybody's going to have to, on this subject, everybody's going to have to develop their own plan on how to tackle this. As we progress, we're still talking about piping and issues with piping. I want to talk about what we're looking for, and so I want you to keep in mind that ammonia is not corrosive. Ammonia is not a corrosive chemical. So you can be 90% confident that there's no corrosion going on inside your piping. Most likely any corrosion is going to be external corrosion, and there's going to be some telltale signs that I'm going to talk about in a minute that lead you to believe that there's corrosion happening. But then there's a 10% chance that there is some corrosion going on, and I'm going to talk about that 10% chance also. Corrosion and wall thickness is a major concern because we want to keep the ammonia inside the system. We don't want it getting out, and if our wall thickness gets too thin, then we're going to develop a hole, and our ammonia is going to get out. And the reason that that's going to happen is our refrigeration system is kind of like a balloon. It's kind of a non-inflatable balloon. The little balloon in my picture here has about 5 psi of pressure to blow that balloon up. And the high side of a typical refrigeration system runs between 130, 180 pounds of pressure. So our carbon steel piping doesn't expand like a balloon. So as we develop weak spots in piping, it's going to rupture so that it can't stretch. And the critical point here is that the ammonia, the pressure it exerts is a pounds per square inch pressure. So so the more square inches of issue we have, the worse, the better potential of a rupture. Looking for corrosion. If you see corrosion during your inspection, if you see a pipe that looks like this, you've got a concern. Other areas as you're walking through and looking at piping and corrosion is if you see large amounts of ice buildup on insulated piping. If you run your hand or you look underneath the insulated pipe and there's some kind of growth, dirt, mold, something under there, that tells you that the insulation is compromised and there's moisture inside there that's causing a condensation problem and bacteria opportunity inside that insulation, or insulation that has holes penetrated in it, or bad insulation. One of the facilities I worked with many years ago, going off subject a little bit, but they had the best line labeling program I'd ever seen in my life. And they had line labels everywhere. And I came to find out that it was a stopgap measure more than anything. They had PVC jacketed piping, insulated piping outdoors, and it had gotten in bad shape. And so anytime they developed a hole in the PVC jacket, they put a line label on it to cover up the hole. So their pipes were really well labeled, and I guess that was a good solution. But if you develop a hole in your protective jacket, it's going to damage your vapor barrier. And once your vapor barrier is damaged, you're going to get moisture down into the pipe. So it's critical that places where we have bad protective jacketing, we address those issues. So in these areas, non-destructive testing could be warranted. And the reason you would want to do non-destructive testing possibly in some areas is that it's expensive to replace pipe. It's going to be expensive to re-insulate pipe. And sometimes if your plan is, I'm just going to re-insulate this section of pipe, once you pull back the insulation, you discover that the pipe is bad too, and you've got to re-pipe it, and you didn't budget for that. So if you have an insulated pipe with bad insulation, you might want to get like radar or X-ray non-destructive testing done before you peel off the insulation, so you know exactly how far you're going to have to go. If it's just replacing the insulation, or if it's having to replace the pipe and the insulation. Rule of thumb. I kind of developed a rule of thumb, and if everybody looks at their thumb, if you can put your thumb over a corroded spot, and if the corroded spot is as big as your thumb or bigger, then that piece of pipe is questionable. It's beyond saving. Going back to pounds per square inch is our concern. Small pinholes that are fairly deep aren't as critical as larger crevices in our piping that have a large surface area because we're dealing with a force, and the more surface area, the less material we have in that surface area to hold back the force of the ammonia, the greater the likelihood for rupture and damage. There's a whole set of equations, I believe they're from the National Petroleum Institute, that talk about wall thickness and corrosion, and you could get into a very technical analysis of your piping, but I think that the rule of thumb is a good rule of thumb. If you can put your thumb over the bad spot and it's bigger than your thumb, it's a bad piece of pipe. The other 10%. So I talked about, I mentioned that 90% of all your corrosion is going to happen on the outside of your piping, but you get a 10% chance it's going to happen on the inside. So that 10% chance, if water finds its way into your system, it can wreak havoc. I mean, if water gets into your refrigeration system, it's not going to leave your refrigeration system. And when we start asking questions, if anybody wants to know, I could tell you some interesting ways water can get into your refrigeration system that you probably never thought about. But once it's in there, it's going to stay in there, and it's going to get stuck somewhere. And it's going to get stuck in a recirculation loop, and it's not going to leave that recirculation loop ever. But when we're talking about water inside a refrigeration system, we have to keep two things in mind, and that is, one, water and ammonia love each other. So they're just going to hold on to each other and hold hands forever and never let go. And oil and ammonia don't mix, and oil and water don't mix. So when you drain your water, people think, well, when I drain oil, I'm going to drain all my water out. And that's not going to happen because the oil and the water don't mix, but the ammonia and the water don't want to let go of each other. So you may get some residual water out from time to time, and if you do see water when you drain oil, you know you got a lot of water in your system. There's other ways that you have to get the water out of the system. So as part of your non-destructive testing program, a good PM program, I think you need to at least annually do samples and do a water quality. When you purchase ammonia new, it's 99.95% pure. That means it's got 5% water, 0.05% water in it. A little bit of water is important to keep the ammonia a little happy, but too much water is hard on our pipes. And this is the type of measuring device that is used for measuring percentage of water and ammonia. And basically, if you get out of that little nipple part in the bottom, so you get more than 1.5%, you've got too much water in your system, and you're going to have to do something about that. If you do have water in your system, it is going to get stuck in a cold place. It usually gets stuck in the coldest place, but it can get stuck, depending on where it entered the system, it can get stuck in any recirculation loop. And it's typically in a recirculation loop that it gets stuck. And the reason it gets stuck there is as your ammonia is going through this process, the ammonia boils off and goes back to the compressors. But the water, water boils at 212 degrees. It's not going to boil. It just stays in there, and then it gets mixed with new makeup ammonia, and it just stays in this cold area. So ammonia samples should be pulled from all recirculators in the system and analyzed. And annually is probably good, especially if you don't run a system that runs in a vacuum. If you run a system that runs in a vacuum, you might want to do it twice a year. Just because there's a greater chance, and I can talk about, if anybody wants to know why, I think that's important. We'll talk about that at question and answer. Oil analysis. Do you do it? I know I've dealt with a lot of facilities that say, oh yeah, we do oil analysis. We pull samples off our compressors twice a year. And I think that's great, and you're going to learn a lot about what's going on inside your compressor, but I think we're missing an opportunity when we just pull these samples off of our compressors. Oil is supposed to stay in the compressor. It's not supposed to ever leave the compressor, but from time to time, for whatever reason, bad coalescing filters or just the nature of our system, oil does get to other parts, and so that's why your operators have to drain oil at these oil pots and stuff on a regular basis. So what happens is Oil travels through our system. It leaves our compressors. It goes through the condensers. It goes to the high-pressure receiver. It goes to the recirculator. It goes from the recirculator to the evaporator. It goes back to the recirculator, and then it ends up in the oil pot. So it's traveled around the system quite a bit before it makes it to the oil pot. And in its journey, it's learned a lot about your system. It's, for one, it's put a protective coat of oil throughout all your piping, which is a good thing. But the other thing is if I do have water somewhere and I have rust and corrosion and debris or whatever, it's going to pick up some of that stuff along the way. And so if I pull my oil samples from my oil pots and I get those analyzed, one, there may be some residual water that I find. I think I say this. I'm sorry. So yeah, at the bottom. So these samples will tell us that what we're looking for is rust, residual water, and possibly metallic flakes. Metallic flakes is primarily what you're looking for when you pull your samples out of your compressors, but there could be other opportunities for them to gather up metal from your pump impellers or from different places. And so it's good to pull these samples. You'll learn a lot about the inside of your system. You'll learn if you got any of that 10% chance of water in your system by pulling these oil samples. As I was talking about piping, that was about pipes and vessels because all this water issue affects pipes and vessels the same way. But I did want to talk about vessels a little bit more, what I want to talk about in vessels is, in a minute, I have Steve switch over to the vessel B109, but is that it asks you a lot of questions on the B109, and it doesn't ask you about corrosion concerns until question J. So halfway down the list, it doesn't even ask you about corrosion concerns, and that's really your most critical thing you're looking for here is possibilities of corrosion externally or internally. A good painting program keeps corrosion off the vessels on the outside, but these water samples and stuff are where we find these issues. So if you'll switch over, Steve, to the B109, and scroll down just a little bit for me. Like you see at the top there, it talks about things that do I still have a nameplate? And that's I talked about filling out the front page. That's good right there. I talked about filling out the front page and keeping it filled out and on file and not filling it out every year. But does this thing still have a nameplate on it? That's an important thing to do every year because for whatever reason, the painter comes along and paints the thing and paints over the nameplate, or the mounting bracket was corroded, so the nameplate fell off. You always got to make sure that annually you are looking for this, because if the nameplate falls off, we want to get that thing stuck back on with something as quick as we can. Don't weld it on, heaven forsake, but glue it back on or something with some kind of really tough stuff. Is it still legible? Did they paint over it? So before we get down to J, and then I'm not really going to talk about J, but I wanted to bring this one up because this is relevant to everything we do. There is a B109, and I'm going to talk about it a little bit, that's about relief valves. However, each piece of equipment that would have a relief valve has questions on it asking about the relief valve. So for this vessel, it's saying, do I have the proper type, a correct setting, capacity correct, installed correctly? So every time that I look at a piece of equipment, that has potential, like a heat exchanger or a compressor or a vessel, it's going to ask me about my relief valve on that. So the purpose of the SRV, the safety relief valve B109, is a double check of all these other times I've had to look at my relief valves. It's an overview of the whole relief system. It says, did I have any no's? Where it says proper type, did I put any no's? Well, if I put one no, then on my relief one, I would have to say no, I have an issue. And this is a way to roll up all these recommendations into one group. So that was the main point I wanted to bring up here, was the relief valve part, because that's going to come up again as I go through my presentation. But then you see we get clear down to J, and J is the first time that we look at the condition of the vessel. So we look at condition, no visible corrosion, slightly visible corrosion, external corrosion, unknown. but it doesn't give us an opportunity to look at the internal issues of the vessel. So the only way we can do that is to get some kind of leading indicator, which would be our oil samples and our ammonia quality tests to see if we have any water. If we have no water, our system's dry, then we don't have to worry about corrosion on the inside. But if we do have these issues with water on the inside of our system, now just looking at external corrosion isn't adequate. Okay, you can switch back for me, please. Okay, so the sheet brought up a good point. Yes, inspections are about Okay, so another thing is if I went through that whole thing, the inspections are about looking at the equipment and making sure that they're in good mechanical integrity condition and the nameplate's still attached and whatever. But it's also about, it's not just in the field looking at the equipment. The operator needs to go back, and this gives them a learning opportunity about the relationship between running the system and what the process and what the PSM program is, and that is that the PSM documentation needs to be correct. And it asks questions on the B109 about things that have to do with the process safety information. Is the U1A sheet on file? So they need to go and verify in the file that it exists. You know, we're talking about relief valves and relief valve capacities. You know, they need to verify that we have relief calculations. They need to feel comfortable as operators in making the transition from putting their hands on the equipment to putting their hands on the process safety information or other parts of the PSM program. Because, like I said, that's all part of the process. That's the business model. It's a system that helps us run this highly hazardous chemical system. So that's part of the inspection, is making sure that making sure annually that the documentation is correct and they know how to get to it. You know, they know where it is. Okay, let's move on. I've talked enough about pipes and vessels and corrosion and stuff like that. So I'm going to move on to another piece of equipment. But here again, the next piece of equipment I talk about is we're going to talk about water corrosion. And so, I don't know, maybe some people will respond. Let's see if anybody responds. Anybody guess? We're going to talk about water corrosion. What piece of equipment in your refrigeration system is most likely going to need to be replaced in the next 10 years? Okay, I think I'll move on. Nobody's going to guess, huh? It's your condensers. Condensers are they're the harshest environment in our refrigeration system. They are just they just take a beating, and it's all because of the water. We're putting water into these things, and we're evaporating water. And when water evaporates, it leaves behind solids that are nasty, and we have to deal with these solids. And if we don't deal with the solids, they decide they want to clump together and eat. I mean, they'll eat galvanized steel. It's a very harsh environment. A good water treatment program is critical, but that's not what we're here to talk about today either. We're talking about, you know, how to do our annual visual inspections on these things and what to look for. The reason that you know, condensers, old condensers, sometimes I've worked with facilities and they say, well, you know, I've got this 30-year-old condenser and it's just fine. I've got this 5-year-old one that's probably only got 2 years life left in it. And the thing is, as all things in the world, I mean, you know, our 57 Chevy was built like a tank, and my little Toyota is built like a Toyota. You know, they've reduced, to save money, they've reduced wall thickness on the tubes, they've changed their galvanizing techniques, they've done a lot of things to cut costs and still stay within the required parameters of the industry. These things, if we don't handle and manage our condensers correctly, are going to reduce the life, and these are the things we have to look for. There's a whole pacification program, a whole way of preparing your condenser when you put a new one in that needs to be followed, and that could be another whole discussion for another day. But when we're looking at these condensers, we need to look for, you know, not just are the fans running, but we need to get up and take the top off. You know, look at the coils. Is there any calcium buildup on the coils? Is the drain pan intact? I mean, that's one of the big problems that I've dealt with in the industry. is the drain pans have just rotted through and they're dripping water out like crazy. And just you got to look at these things. This is a one piece of equipment that doesn't have a long life, and we need to look at and address the concerns that we may find with this thing thoroughly. And so it's a good idea to inspect these in the colder times of the year when you can shut them off, and whatever your facility's rules are about confined space entry, go inside these things and look closely at the condenser coils and get a good assessment for the condition. I've seen some where the condenser coils were so overwhelmed with calcium that the water ran down the outside of the block that used to be coils and nothing went through the coils. And then they don't understand why they're running such high head pressure. So keeping a good, clean, healthy condenser is going to save you energy, but it does require actually shutting the thing off and climbing inside to inspect these things. I'm going to move on to evaporators. Evaporators, we still can't get away from water. Water's still an issue. Water is an issue only in evaporators if you are a food processor that has a sanitation program. If you're a cold storage facility and you never wash the thing, then your chances of water corrosion are a lot less. But sanitation workers, they tend to wash everything without regard. And spraying water, you can bend aluminum fins, you can damage coils just with the water pressure. But the chemicals we use, the chemicals that are typically used in sanitation, they'll eat aluminum, they'll eat carbon steel, they'll eat galvanized, they'll eat these things up. And so we need to inspect them closely. The drain pans, I didn't put this on here, but the drain pans is critical. Looking inside the drain pan for any kind of growth. Bacterial growth is a really, from a food safety standpoint, that's a really bad thing. And it's not going to affect the coil, but when we're PMing, when we're doing our annual visual inspection, in addition to, you may have a PM that says clean the drain pan 3 times a year, and then sanitation cleans it once a year. In addition, we should get up there and inspect the drain pan closely and make sure that there's nothing growing inside that thing that needs to be cleaned up and addressed. There was a facility that I worked with recently that had a USDA-approved little pellet that they put inside their drain pan that killed everything. And I think I have the information on that. If anybody afterwards wants to know what that was, they can email me and I'll send them the information. But I thought that was just revolutionary, that there was something I could put in there that USDA said was okay that would kill some of this bacterial growth. Compressors. Well, finally, I think we can get away from water. When we're dealing with compressors, one of the critical things is listening to them. You walk by these compressors every day, and you get to where you know what they sound like. They sound a certain way. And if you stand there and listen to them, and they tend to, the pitch changes or something changes in the way they sound, we need to investigate that, and that needs to be part of the annual visual inspection process. Is listening. Does this thing sound like it always sounds, or is it sounding a little different? And then we can start looking into why is it sounding different. What is causing these? There could be anything from liquid slugging coming back to, let's say, a bad push rod on a recip compressor, or out of it's out of balance, or whatever. There could be a lot of issues that listening to the equipment will bring out that looking at it won't. Because all we can see when we look at it is it well painted, or is all the wiring inside of the wiring tubing, things like that. So listening when it comes to compressors is a critical part of this inspection. And then another thing about that compressors bring up is how many inspections. B109s, there's a B109 sheet for compressors, for vessels, for heat exchangers. But when we do a screw compressor, that screw compressor has all 3 of those components. So when we develop our PM program, our program for doing our annual visual inspections, we need to somehow know and group this, because it wouldn't make sense to have 3 PMs come out for one compressor on 3 different days that say, go inspect the compressor. Then 2 weeks later, go inspect the oil separator, then go inspect the oil cooler. We should do all three of those sheets at one time, and that would be the same with, say, a flooded evaporator. If we have an evaporator with a surge vessel, then we should do both of those inspections at the same time. Or a large facility, if you have 10 pieces of refrigeration equipment in one room, you should do all 10 pieces of equipment in that one room on that one given day instead of having to go back into that room 10 times to do those. So when you're developing your PM program, you need to make sure, your inspection program, you need to make sure that you group the inspections in a logical manner. Going back to that saving time thing, you fill out the front sheets and you manage your front sheets with the MOC process, it saves you time. If you group all of your inspections properly, it's going to save you time. So that's important, and Compressors brought that up, and that's why I put that in here. Heat exchangers. Okay, now we're back to this pesky water issue again. Water is just not ever going to go away for us in refrigeration. Okay, this time we're looking for more than just corrosion. We have the possibility of ice damage. I just put 3 pictures of 3 different types of heat exchangers. I didn't know that one on the right did all the things it does until just now, though, but that's kind of cool. The far left, and I don't need to go into the details of what they are, but the far left one is usually used in the milk industry, orange juice. It's a Fildemeyer tube-and-tube heat exchanger. The middle one is a plate and frame, usually in the beer industry, things where we do not freeze our product. And the last one, shell and tube heat exchangers, usually for really low temperature applications, also for your thermosiphon oil coolers on your compressors. Interesting thing about ice, if you trap ice between 2 places and it has nowhere to go and it wants to continue to grow, its force, its pounds per square inch is 115,000 pounds per square inch of force it can build. That's more force than anything our refrigeration system can handle, and it'll quickly rupture or damage a tube or push plates apart on a plate and frame. And so we really got to look for ice on these heat exchangers in places that we didn't expect it, because it'll destroy that piece of equipment. And unfortunately, it tends to do it pretty quickly before it's even time to do our annual visual inspection. We've had the problem and we've had to fix the problem. Okay, so but ice. Since I brought up ice, I want to talk more about ice. Let's go back to piping and vessels for a second and talk about ice. The obvious ice issue is weight. Everybody says, well, if we got ice on this suction line, is it putting too much weight on the pipe, and is it going to bend the pipe? That's an obvious concern, or way down the roof and cause the roof to collapse. That's an obvious concern, but I'm not here to state the obvious. We can see that. What I want to talk about is corrosion in ice. And ice and corrosion have a very interesting relationship. Ice is a really good insulator and a very good vapor barrier protector. If you have a piece of unpainted, uninsulated pipe, and it always runs at 10 degrees Fahrenheit, and it stays at that temperature forever, that pipe will never corrode. It's perfectly insulated, perfectly protected by that ice. But if I if I have ice on a line that goes through freeze-thaw, it's a suction line that, say, to some evaporators that have hot gas defrost, it has some level of freeze-thaw so that the surface area between the pipe and the ice can melt and refreeze. I have a tremendous corrosive opportunity. It'll just eat the pipe, just eat it away. So ice is interesting because in one case, it's the best protection. I mean, we don't want it, but it is really the best protection that pipe could have. But if it has any chance of the surface between the ice, it's not the outer surface of the ice, but the surface between the ice and the pipe have a chance of melting and refreezing, then the corrosion opportunity there is just tremendous. And so this is why we really need to be concerned about seeing pipe on ice or vessels or things like that, because if there's any freeze-thaw opportunity with that surface, there's a tremendous opportunity for corrosion. Ice and corrosion, okay, and that's what I just said here. If it goes through freeze-thaw cycles, it's likely for extensive corrosion. This is a good opportunity or a good time to bring in the non-destructive testing folks and see what's going on. I mean, you can also thaw out the ice, I guess, and look at the pipe. But it's not always. Sometimes it's not practical to do that because we got to keep our system running. So you bring in the people that do non-destructive testing using X-ray technology. They have a tool that they can just, it's like a wand that can run over your pipe, and they can adjust for the density of ice and give you thickness of your piping even without thawing it out. So I want to talk some more about ice, and that's the priorities. When I finish this presentation, I'll talk about managing your recommendations and how to develop a plan to resolve them. But right now, I want to talk about ice and priorities. All ice where it's not expected is bad. I mean, there's places where we see ice all the time, on certain valve groups, on the suction valve to our compressor, on valve groups where the insulation is on both sides, but the valve group is uninsulated. We see ice. There's certain places we see ice, and we know to see ice there. We expect it on our oil pot, places like that. The places where we don't expect to see ice, if we see ice there, that's bad. So, like I said, if it goes through, so when we prioritize what bad places of ice to resolve first, the places that stay frozen all the time, they can wait for a later day. But the places that go through a freeze-thaw cycle, when I'm trying to manage what issues I need to address first, those are the areas you need to address first, are places that have that chance of going through freeze-thaw. Those would be your highest priority recommendations of all of them, probably, not just on piping to resolve. Ventilation, now I'm hopefully done with piping again, but ventilation, there's a ventilation annual visual inspection sheet, B109, and it asks a lot of questions about, do I have enough ventilation? One thing about ventilation is never take the manufacturer's cut sheet on the fan as the gospel when it comes to the amount of air that fan is moving. When the manufacturer made that fan and they calibrated it, they had very set conditions of how much pressure was in the room that they're pulling against. Those conditions aren't going to be the same in your engine room, so you need to physically measure the amount of air that these fans are moving. And I think you should measure it annually when you do your annual visual inspection. You need to get like an airflow meter. Even if you don't do the math and convert it to cubic feet per minute, if you just document it as feet per minute, as the airflow meter will tell you, at least you'll get an indication of if it's changing. There's a lot of things that could change. I mean, something could get in there to damage a fan blade, therefore causing less airflow. Something could, the belt that drives the fan can stretch, causing less airflow. There could be an impedance on the makeup air that's causing more pressure in the room, harder for the fan to pull the air through the room. There's a lot of things that are factors in reducing the amount of airflow we have. So we need to, we should measure this airflow annually so we know that we have what the regulation says we should have. But I also wanted to bring up a point, and I'm not going to jump over to the B109 to do this, but I wanted to bring up a point that IIAR does things, but they don't always fix everything that they do simultaneously. And IIAR in 2008 changed the way ventilation is calculated and what the requirement for ventilation is. But they didn't change the B109 to reflect that. And so when you look at the B109 for it, it says that that certain ventilation has to alarm. The emergency ventilation has to alarm. No, excuse me. The continuous ventilation has to alarm if it stops. That's because the old formulas, the old way we calculated and designed our ventilation systems, we had continuous ventilation and emergency ventilation. Now, with the new rules, we have what we call normal ventilation and emergency ventilation. And so with the new rule, now I have to put alarms on all my fans because the rule says if I have a fan and I have it in the on position and there's no air flowing across the fan, it needs to alarm to tell me there's no air flowing. Used to be my continuous ventilation, I had no way to turn it off. And if I did turn it off, it would alarm. So if the fan belt broke or something happened, it would shut itself off. I mean, it would alarm that, hey, I'm not moving air. Well, now I have the flexibility because especially people in like the Midwest and the Northeast where it gets pretty cold, they don't want even 200 or 300 CFM of airflow. They don't want that going through the room all the time, in the winter. So So they changed the code a little bit to give us this freedom to turn that off. Or if it's in the off, if it's in the off position, then therefore I don't expect airflow, it should not alarm. But if it's in the on position and I don't have airflow, then all of my fans that are in that case need to alarm. So that's the change. That's how you have to physically kind of scratch out and rewrite some words on the B109 in order to comply with the new codes. Now back to relief valves. Like I said, each sheet, like we looked at the vessel sheet, each sheet asks you some basic questions about the relief valves. But then there is one sheet that asks you specific questions about relief valves as a whole. And this is where your refrigeration guy not only looks at every relief valve in the system, but now we got to go and we've got to sit down, and maybe this is a task not for the refrigeration hourly operator, but maybe this is the sheet that the refrigeration supervisor, plant engineer, somebody else fills out this sheet, because now we need to make sure that all the valves we have in the system are the right valves, that they comply. You know, everybody knows that every 5 years we got to change our relief valves. I don't think it's unheard of that somebody accidentally changes a relief valve and puts the wrong relief valve back on in place. That's part of what we're looking for when we do this exercise. And this is a roll-up. This is a summary of all of the inspections and making sure that we have the right relief valves where we need to have them. You know, is the right valve on the component? You know, is its operating pressure lower than the maximum allowable working pressure of the vessel? Is its discharge rate correct? Well, I got to look at the calculations to know what the discharge rate is. Is the manufacturer's seal still in place? Especially if you have relief valves that are on condensers, or if they're in a sanitation washdown area, the cable that holds the lead seal is a galvanized, carbon steel galvanized braided cable, and it doesn't hold up very well to washdowns or humidity and stuff like that, so they can break. So if that seal is broken, in a regulator's eyes, that valve is no longer good. So that it won't live for 5 years by regulation. It has to be changed early. So that's a critical part of this inspection, of all these inspections, and this is where we would say these are the valves that have broken seals. I have a solution to that, and if people want to email me, I can tell you how I can deal with that to get that life longer with that seal. Are all the SRVs less than 5 years old? You see that little blue tag that hangs on there? That blue tag is supposed to indicate when the relief valve is due for replacement. That little blue tag is being held on by the seal wire, and it's just a little plastic thing that in the wind will rub back and forth and rip off. So chances are that thing's not going to live for 5 years, even if the valve does live for 5 years. So there needs to be another Excel spreadsheet, some other thing that identifies this as a valve with a number, and this is its due date for replacement, because I can't rely on that blue tag either having even been punched correctly, or still attached 5 years later. And then discharge points. This is becoming a really critical thing, especially for facilities that have to deal with the new national emphasis program. I don't know how California falls in that, but the rest of the country is dealing with the OSHA National Emphasis Program. And let me tell you a situation I had. 15 feet from the nearest standing area. It doesn't say that in the regulation. It says from terra firma. Well, OSHA has chosen to decide that terra firma is anywhere you can stand. And I had a relief valve that if you measured it from terra firma, from ground, it was about 75 feet in the air. But they had let me say something more about PSM. In PSM, everything in PSM is interrelated, and one change to make something better can make something worse. And here's a case that I'm describing that is that case. This facility had a problem accessing the upper valves on their condensers, so they put an upper catwalk on their condensers to make those valves more accessible. They didn't do an MOC because they didn't feel like they had to, because it didn't touch the refrigeration system. And it should have been an MOC because we should have looked at all the implications. Well, when the OSHA regulator got there for the National Emphasis Program audit, he spent a good 45 minutes trying to figure out how to measure at about a 20-degree angle from where you could stand on this catwalk to the discharge point of the relief valve, and relief header, 8-inch relief header. Turned out that because we added that catwalk, now the distance was only 11 foot 6 inches. 11 foot 6 inches is a $5,000 fine, and it would have been fine if we wouldn't have added that catwalk. So it's important when we do this inspection that we make sure that we didn't do something in the past year that made our discharge points less than 15 feet from where we could stand. General safety. We're going to go over to the B109 for general safety. Steve is going to navigate us to that. And if you scroll down a little bit for me, questions questions A, B, and C. You know, I was talking about when you do a compressor, you got to do a compressor, a heat exchanger, and a vessel. But also, questions A, B, and C apply to every piece of equipment. So I don't know how you want to manage this, because just doing this once doesn't suffice. Guards and valves installed at vessels. I can't say that as a broad statement of my whole system. I need to say that piece of equipment by piece of equipment. So unless that piece of equipment on their B109 asks that question, I'm going to have to ask these 3 questions for every piece of equipment in my system. We'll go ahead and go on down some more. Steve, bring D to the top of the page for me. Main shutoffs. Everybody's aware of this. We got to label our king valve thing. We also need to know where our main hot gas valve is. It doesn't have to be labeled anything special. Maybe main hot gas valve, but I've seen it labeled as queen valve or prince valve, or I don't know how you come up with those. But we need to know where our main feed sources are. And in this modern day and age, number 3 is the most critical thing, because we can shut what we call our king valve, our main high pressure liquid valve, to a system, and it's going to keep pumping ammonia forever because we're recirculated systems. It is that pump. It's the pump process that we need to make sure we know where that main shutoff valve for feeding liquid out to the facility from the pumps is. Main shutoff valves are accessible. Can you get to them all easily? Main shutoff valves can be closed from outside the machine room. Yeah, that's important. I'm not a real big fan of motorized isolation valves, but if the hazard were to occur inside the engine room, there's a way to isolate the liquid. If your high pressure receiver is outside, closing your king valve hopefully will stop the feed. But is there a way to isolate and shut the liquid off, or the flow of ammonia off from outside the engine room? Oil pots installed at all points where oil pots must be installed. That's a question for you guys to talk to each other about. I mean, when I do a PHA and I ask that question, they'll say, oh yeah, we don't drain oil anywhere other than where we have oil pots. And then I proceed and I go through and I ask questions about a heat exchanger, and they say, and something will come up and they'll say, oh yeah, when we were draining oil on that, we should put and I said, wait a minute, you said everywhere you drain oil. I said, well, maybe once or twice a year. You got to figure out what frequency of draining oil warrants an oil pot. Once or twice a year may not warrant an oil pot. It may just warrant a spring-loaded valve. But we need to determine if we think there needs to be an oil pot there. And so if we think there needs to be an oil pot, then we need to make sure we put a deficiency. Starting in I is a really cumbersome thing in our modern age of the sign that goes on the door. I think when they developed this, they thought that when you built a refrigeration system, you were going to hire a contractor and to install it, and he was going to take care of the thing, and you would just be good forever, and you'd never change the type of oil you use, and you would never expand the size of your system, so your quantity of ammonia would never change. I think they felt like that was going to be a static thing, that these are very dynamic things. this whole thing about name, address of installing contractor, I think you need to come up with something other than that. If you are a company that uses a third-party company to service your system, then that company needs to be on there. But if you have your own refrigeration staff and you use the lowest bidder to come in and do your next service work, then that information needs to be pertinent to the facility. That it needs to be the refrigeration supervisor as the contact for service and maintenance, or you need to come up with, you don't have to have it be a third-party company that's on there, but it does have to be somebody that has ownership responsibility for the maintenance of the system. Quantity of ammonia, that's whatever that's your maximum. That's not your true inventory. That's this whole thing of your calculated maximum intended inventory, because nobody is ever going to know how much ammonia you truly have in your system. Even if you pump the whole system down and said, I evacuated everything, I still don't think you would ever know exactly to the pound how much ammonia you had in your system. Lubricating oil, hopefully you only change that when, a couple times in the lifetime of the system, because it can cause havoc if you do. So you can put that on there, what type of lubricating oil. And your field test pressure, really, that can be whatever the large, because I don't know if they always do when they build a new system, and if you're inheriting an old system, you're not going to know what they test pressure the thing up to. But whatever your highest maximum allowable working pressure is, if if one of your vessels is a 300-pound relief valve, maximum allowable working pressure, then that would be the highest test pressure. But I don't think you want to use that one, because if you have some 150s, so you got to decide, am I going to use the lowest or the highest? But have a reason you chose that. And I think I would go with the lowest. If you had a 150-pound vessel, you don't want, really don't want anything in any part of the system charging up over 150 pounds. You want to go down a little bit more for me, Steve? Written evacuation plan. You need to have, even though there may be only one or two doors in and out of your engine room, you still got to have something on the wall that says this is where you are and this is how you get the heck out of here. Housekeeping is important. System free of abnormal ice formation. That is another roll-up question, because we're going to have talked about that in our piping stuff. Eye wash and shower. This is really important. Your eye wash and shower needs to be located within 15 feet of the door that exits outside the door that exits your engine room. You can also have them inside your engine room, but you can't have them inside your engine room instead of outside. So they need to be at least one within 15 feet of the door that leaves your engine room, and you need to test to make sure it works. Ammonia masks. Unless your facility conducts fit test, pulmonary fitness testing, and physicals, and assigns your people masks, there's some issues with the whole mask thing. So you need to have a program for that before you just say, well, I have masks hanging on the wall and anybody can grab one. I think that I've covered this good enough. If we can go back to the PowerPoint. Okay, then pumps, and I apologize, I'm going to send Steve back over. Pumps are pretty straightforward. There's not much to talk about with pumps, but we'll just look at the sheet real quick on the pumps. We're looking there again for the label on it. And I want to say something about label, because everything is going to ask you is the label on it. And there's only certain things that have to have nameplates on them by regulation. That is, heat exchangers and pressure vessels have to have a nameplate. If your evaporator or your condenser or your pump or whatever, if the nameplate is gone and not legible anymore, but the thing works just fine, there's no regulatory requirement to have to replace that thing. So be careful when you fill these things out. If it says no nameplate, the guy has to inspect it. He has to say there's no nameplate on it. But we need to somehow address that as management and say no nameplate required, equipment working within accepted parameters, somehow address it so that the regulator doesn't pull the sheet and say, well, it says no nameplate, what do you do about it? Operating within limits. I wish that these sheets had more than yes and no. I wish there was an unknown, because I don't know if the operator would ever know, and I don't know where he would find out if the pump speed is correct, if his design pressure is correct. That's kind of beyond even me as an engineer to always be able to dig up that answer. It's not leaking, and it's pumping ammonia, and it's working. But the important thing is free of excessive vibration. Is the sound, is it making a sound or anything like that? So pumps are pretty straightforward, not a lot of questions, and some of them we can't even answer. So if it's an unknown, just instead of putting yes or no, just in the comment column put unknown. And if you'll jump back over to the presentation, deficiencies. Now, we've talked about all the pieces of equipment, and we've talked a lot about water, because I think water is our #1 culprit when it comes to damaging our refrigeration system. But what I want to talk about now is, as you fill out these forms, people are going to put no's, and they're going to put, if they put a no and they don't write to do something, somebody's going to have to come up with a plan to do something, or a comment that says that this is, we don't have to resolve this because it's not required to have a nameplate or whatever. But as a corporate PSM manager for so many years, I learned a valuable lesson, and the valuable lesson I learned was my #1 job, and the #1 job of everybody that runs any refrigeration system, is managing our recommendations and moving those recommendations forward. We can hire consultants to come in and do PHAs and compliance audits, and they're going to make the recommendations, but we got to figure out what to do about these recommendations, and we got to do something about them in a timely manner, and document how we did it and what our plan is if we haven't finished it. And basically, I think if we make a annual visual inspection recommendation, we have to prioritize them, but the low priority ones, we better resolve those lowest priority ones within a year, and the highest priority much sooner. Identifying and unresolved deficiencies. If somebody says on a sheet there's a deficiency and you haven't resolved it, that's just an open door for regulatory problems. I mean, if somebody writes something on a piece of paper, it becomes discoverable, and we need to address it. And that is a stopping point for me. Does anybody have any questions?
Thank you, Scott. So basically what we're going to do is we're running a little bit late on time, but given Scott's available, want to make sure that we provide an opportunity for everybody here and also who may be tuning into the WebEx. If you have some questions that you'd like to bring up, as I mentioned before, the chat window is an opportunity to pose your questions, and our producer, Solveig Sather, will go ahead and echo those, and we'll go ahead and pose them to Scott and go ahead and present the results to the team. We've also got an opportunity to unmute you if you'd like to start a discussion. I noticed from some of the sign-ins that we had several regulators that have also tuned in. If any of the regulators would like to provide some insights in terms of how they use the B109 audits, audit findings, what sort of things they look for when they come to a plant site, I'm sure that would be valuable to the industrial community. So if you'd like to go ahead and join in the discussion on that, or add something to it, I'm sure everybody would benefit from that. So chat window has to be unmuted. Anything goes with respect to asking questions at this point. Oh, good. I'll remind everybody how to find the chat window. All right, so at the top of your screen, you'll see a little green bar. For most screens, it'll be about maybe 3/4 of an inch wide. If you hover over that, you'll get a window that kind of materializes right from the top of your screen, and it will give you a number of options. One of the boxes says chat. If you click that, it will open up a separate window. At that point, you'll want to choose the producer's moniker, RMP CORP, and that'll be something that you can then use the chat window to pose a question. Did I do that right? Okay, very good. Sure. In fact, unless you need me, I'll let you go ahead and take care of the question. I'll come back as needed in this slide.
Okay, we have several questions coming up here. First one is, when is an MOC required?
Oh boy, we could do a whole separate presentation, and maybe that's something we ought to think about. But MOC is required anytime you make a change to the system that would change any piece of the PSM documentation. So if it affects the way the SOP is written, I was talking about the front page of the B109, if it affects the serial number that's on the B109, if it affects the way the valves look on the PNID, anytime it affects the refrigeration system documentation, it's an MOC.
Just to add to that a little bit, as part of our outreach program, we have done MOC presentations. So if you'd like to look at the outreach page, you'll probably see a video of that. If not, go ahead and call in at that main number, 877-532-0806, if you do have a question about MOC. A lot of that pivots not just on the documentation, but also the design and how you operate it. Anytime you're designing something or replacing equipment where it's not a replacement in kind, I believe is the correct terminology, that's when you'll need to go ahead and properly evaluate, does it have a safety impact? Same thing applies to operations. If you're changing the way you operate it, such that you may be operating outside the context of how it was designed or the operational intent, you'd want to at least have some degree of assessment. A lot of people use a single-page checklist, and as necessary, when there are some uncertainties with respect to does the change have an impact, you may invoke some sort of process hazard analysis to more thoroughly investigate that.
Yeah.
Okay, second question is, PSM requires inspection and test frequencies consistent with applicable manufacturers' recommendations and good engineering practices, and more frequently if necessary. Are there common pieces of equipment that require more than the Bulletin 109 inspection frequencies and techniques, or does Bulletin 109 encompass most regulatory requirements for inspection and testing?
There are certain pieces of equipment. The condensers may need to be inspected more than annually, but the manufacturer doesn't spell out that that's the case. That would be something that the facility would learn because of their condition. Certain evaporators inside of washdown areas, things like that, the facility may choose to have a more frequent inspection rate, twice a year or something like that. But the industry, all the manufacturers, they kind of look to IIAR as the guiding light, and IIAR kind of uses them as their backup, and everybody's kind of agreed that if you do the PMs we say, and then you inspect it annually, you're pretty good.
Okay, thank you. Are you finding that regulators are reviewing the B109 audits as part of their mechanical integrity inspections? And are there any common deficiencies in the B109 audit performance or audit results for ammonia refrigeration systems that you would like to share?
Are they reviewing them? Yes. I dealt with a situation where a facility was doing a very good job of doing their annual visual inspections, filling out their B109s, and year after year, the operators were finding the same deficiencies. And so the auditor pulled 3 years of inspections, found 3 years of basically the same deficiency on one piece of equipment, but couldn't find any follow-up action from the facility to resolve it. And it turned into a $230,000 fine. So yes, they are looking at those. It's easy for them to. It's an easy thing for them to find and get you with. What was the other part of the question?
Let's see.
Was that it?
I think you answered it,
okay.
and the next one kind of ties in. Have you seen cases where OSHA or other agencies have levied fines based on a 109?
Yeah, the worst I've dealt with and had to address was, first they wanted to fine us $18 million, and we got it down to $208,000.
And I believe, oh, We have one more. We have two more questions. When a manufacturer recommendation for frequency of inspection and testing conflicts with a recommended good engineering practice inspection frequency, and the rule requires compliance with both, what do you recommend?
Okay, well, I recommend that you do it. If it conflicts, you still got to do it at least annually. If they're saying every 3 years you inspect it for something, then your annual should cover it. You know, you've always got to take, you know, what the guideline says first. The guideline says every year. If they have a different frequency, then if you're doing it every year, you should cover that too.
Well, do you have to do whatever the more frequent item is?
Yeah, if it was a pump, say, and the pump manufacturer, that wouldn't conflict with the regulation though. If they said every 6 months, then that's above the code. So that, I wouldn't say that would be a conflicting requirement. Yeah, you would just do it every 6 months, satisfy their needs. But if they said every 3 years, then that would conflict with the code.
I believe this is our last question. Is there a requirement to have an outside contractor conduct the B109 audit, or can it be done using plant or corporate staff?
If we jumped back to the B109 form, it says, I would like to read the exact wording that it says, and then I can tell you what I think is a good idea. It's going to be at the very top. It's going to be the very last part of the wording. So, yeah, it's going to be down more. Sorry. Past, like right before the first sheet starts. Yep, go right up just a little bit, right here, inspection checklist.
On page 13.
No, it should say frequency. Maybe it's up more than that. I apologize.
I think section 14 is frequency.
There you go, right there, frequency. 5.3. A more thorough inspection of an ammonia refrigeration system should be conducted by a competent ammonia refrigeration engineer. I don't know why they put fire official. I don't think that they would be necessarily, I don't think OSHA would consider them qualified, or other authority. And I know that, if a regulator comes in and does their audit, they're definitely not going to say, my audit would cover you for a 5-year mechanical integrity. So you really get boiled down to competent ammonia refrigeration engineer. Well, I guess other authority could possibly, not authority, but you can use competent refrigeration technicians to do that. But what it's saying is that it has to be somebody that's not involved in the day-to-day operation of that facility. So if you have a company, this is my thought, and I think there's a lot of value in this. If you have a company that has like 5 facilities or 20 facilities or 50 facilities, if you were to develop a program where you took 2 guys from 2 separate plants and you went to plant A and plant B, and those 2 guys went to plant C and conducted the audit, I think that would cover this. And I think there's a lot of value in doing it that way, because if guys from plant A and plant B go and they say you don't have enough line labeling, so I'm going to make a recommendation you put more line labeling, hopefully they'll go home and say, I just told this guy he didn't have enough and I don't have enough either. Hopefully they'll address those things. Or on the other side, they may inspect this facility and find something that this guy's doing that they never even thought about doing, and hopefully they go back home and implement that. So from a company standpoint, if you have a big enough company where you can share the knowledge and do that, this is a valuable thing. But you also want to back that up with somebody that has engineering experience outside of the company to kind of as the overseer of this process, of this inspection.
Scott, is there anything else you want to add?
No.
All right. Well, in that case, I just want to thank everybody for tuning in. Thank you for joining us as part of our ongoing outreach program for process safety management and risk management programs. And if you do have any follow-up questions, Scott had provided the email address and good contact points at the end of the presentation. Feel free to ask. It's very involved. A lot of people have gotten in trouble by not implementing these things properly. So, you know, we're happy to receive questions and help out a bit. Thank you. Okay, you can go ahead and end it. And